Hello guys, I wanted to do question 4, the question that I said I was going to solve the talk using a different reference point. Okay, like I said yesterday or in the previous video, um, the reference point that I had taken at first was with reference to the wall when finding the talk. Okay, then I found that it was way longer to take this as the reference point compared to taking this. So I had to change the reference point and took this as the pivot. But when I changed the pivot, I forgot to change the fact that the perpendicular distances are going to be different again. Mind you, if I take this as the reference point, the perpendicular distance of this force is going to be this distance. The perpendicular distance of the center of mass was going to be this distance. Okay, that was my initial calculations. But then when I changed the reference point, I forgot to note the fact that if this force is acting here, then the perpendicular distance was going to be the distance from here to here. Okay, this was going to be the perpendicular distance, and meaning that if I take the force, I take this force here, the perpendicular distance is also going to be the distance from here to here. Okay, so when I was calculating in the previous video, I was using these distances instead of using these. Okay, this one here and this one which is here. Okay, so meaning even when I had found the distance of 1.9 meters, it didn't make sense that this is 1.9 meters. Okay, because this is way too small. It cannot be 1.9 meters. So the 1.9 meters would only make sense if it was coming from this point to this point, right? And I also had made some errors, especially with my tag when I was using tension in place of torque. Okay, when solving this very particular question. This question had nothing to do with tension, it was all torque. So at most of the points where I was talking about tension, those were errors with, with my tongue. I was thinking torque, my mouth was saying tension. Okay. So I wanted to solve this same question using the changing the pivot in short. If we change the pivot, how we can solve this question. Okay, so I'll have to redraw the diagram here so that we'll have the force, which is the 200 Newton force, and then the 600 Newton force, which is with reference to the weight of the person. Then we had F4, we had Fg, and we had the force of friction. Okay, so I'm going to still consider the forces that we had found earlier. We found the forces Fg to be equal to 800 newtons. Then we found theta to be equal to 53.13 degrees. We also found force of friction to be equal to 360 newtons. Then we found this F4 was also equal to 360 newtons, since these two were acting in opposite directions and in the same axis. That's what we had. Then we went to finding the tension, the torque, back to tension, the torque. All right. So now, if we are going to find the torque with reference to the wall, okay, we will have, of course, the distances were given to be 5 meters. This was 5 meters. This was 3 meters, and we took this as, we calculated this as 4 meters. Okay, so this is what we had. Then the theta there is calculated. Like I said, this is also going to be equal to theta. This is also going to be equal to theta. That's what we have there. Okay, so now if we're going to find the torque with reference to this point, if we take moments about this point, we'll have this force, this force, this force, and this force. Okay, so that we'll use that information to find out how high up the ladder the person had to climb. Okay, now the other information that we had calculated when we had solved the question previously was that this distance here was 1.5 meters. Okay, that is not changing even if we take we take a different pivot. That will be that. Okay, so now if we are going to find the torque, summation of torque is going to be equal to 0, right? Meaning that we are going to have forces acting, said clockwise is negative and anti-clockwise is positive. Okay, so clockwise, if we take this as our reference point, this will be clockwise. Okay, so it will be negative, and we do not know this distance. Okay, we don't know the distance at which the perpendicular distance of this force. So we're simply going to say negative, okay, I can say negative x 600, okay, minus 1.5 multiplied by 200 minus, now if we look at the forces that we have here, we've got this force which is acting with reference to the ground, and we've got this force which is acting with reference to we've got the force of friction. Okay, now this force of friction is going to cause this to go in the anti-clockwise direction, so it's going to be positive. So we'll have positive 800. Now the perpendicular distance is going to be equal to 3 meters. Okay, multiplied by 3 minus this force, okay, which is going to be 360 multiplied by the perpendicular distance is going to be 4. Okay, okay. So if you take note, the force of friction is acting in this direction, meaning it is perpendicular to the 4 meters. Then the force with reference to the ground is acting in this direction, and it is the perpendicular distance is 3 meters. That's why I've used this. So after simplifying, if we simplify this, we're going to get negative 600x being equal to 660. Okay, 660 divided by 600 divided by, of course this is going to change because it has gone the other side, it's taken the other side of the equation. So x is going to be equal to 1.1 meters. Okay, now the 1.1 meters that I've just calculated is this distance here. Okay, that's the distance we are looking at. This is the perpendicular distance of this force with reference to this as the pivot. Okay, now if you look at it, we are looking for the distance from here to here. Okay, that's the distance we're looking for. How do we get that distance? We can simply find the distance here and subtract it from 5 meters. Okay, so to find this distance here, we're simply going to use r cos 53 is going to be equal to 1.1. Okay, meaning that r is going to be equal to 1.1 divided by cos 53.13, of course. So r is going to be equal to 1.8 meters. So 1.8 meters is the distance from here to here. That's the distance that we have here. Now we want to find out how far the person had moved from, how far the person had climbed up the ladder. So meaning we're going to find the distance from here to here. And we know the complete distance here is 5 meters. So the person will have to climb a distance of, So we'll say hence the person will climb 5 meters minus 1.8 meters, which is going to give us 3.17 meters, round off. Okay, so that's the distance we've calculated, and that is the distance that is from the ground to here. Okay, so that's why I said that taking this as our reference point was going to involve more work than taking this as the reference point. This one is direct. Okay, when we were calculating in the previous video, it was direct. It was just a matter of finding the torque and drag, and it was able to give us the perpendicular distance here, and then we used it to find r. But with this one, it is a bit longer, because after finding the perpendicular distance here, I'll have to find this distance and then find the other distance. Of course, I think in mathematics there is a way of finding no, I don't think so. Anyway, so that's how to go about solving this question. Okay, right. So the tutorial, question 5 still stands that you're supposed to submit on Sunday. I've had a bit of challenges with my network, but I'll post this as soon as possible.